Hello, it's Duncan. The last couple of episodes have been pairing with Lucas Ada to learn about the jOOQ SQL mapping library. We ran out of free consultancy before Lucas was able to explain how to use database transactions, so in this episode I have to work that out for myself. Having done that, I listened to the spider sense that is telling me that we have a logical issue in our persistence, write a test to show that I was right, and then fix the test with a bit of a hack, but one that might stand the test of time. Lucas left us with a working jOOQ item type, the implementations of this items repository, but without working transactions. Now, that's less of a problem than it would have been with exposed, because when we load, we're doing it inside one SQL statement here, but we're still left with stop, which wants to run two things inside one transaction. It wants to load and save the items in this one transaction block. So let's look at how we can get transactions working within jOOQ. This would be easy to mess up, so I'm going to write a test for it. And I'm going to put it inside the jOOQ items tests as a test just for jOOQ at the moment. So we'll add a test fun transactions. Now what we want to be able to do is write a test that fails because we aren't using transactions. And transactions are all about running things in parallel. So a sort of thing we want to be able to do is say in a thread, and that's creating and starting a new thread in Kotlin. We would like to take our DSL context and use it to save our initial stock list. And now in that same transaction, we're going to wait a little while. So I'm just going to thread sleep in here for now, say half a second. Now, while that thread's running and in a different transaction, we'll make sure the thread is running at all. So we'll just thread sleep for say half that time. And then we're going to say what happens if we load. So we'll say DSL context load, and if we have transactions and they're working, then that should be the empty stock list and not the one we're saving in this other transaction up here. So this should be, I think I called it null stock list, is what happens if you load. And that's assert equals. I'm going to run all the tests in here and see what we get. Okay, that does fail, and it fails because we expected, well, we didn't really expect, but when this passes, we'd like to see that we get no saved stock list effectively if we ask the question before this transaction's finished. Now, we don't have any transactions here at the moment, so this isn't working. Before we go on, though, these sleeps aren't very helpful. What I think we're going to do is we're going to create a cyclic barrier. And this is a way of communicating between two threads so that they both end up at a synchronization point. So we've got two threads, so we'll have a cyclic barrier of 2. And that means that in here we can say cyclic barrier await. And if I say cyclic barrier await in here, then both threads will wait at their respective await points until both of them arrive, and then they'll both be let go. Let's run and see what happens there. And so that has the same effect. Okay, how do we use transactions in jOOQ? Well, here's the documentation, and it says that we take a DSL context we've already got, this one here, and we call transaction on it, which gives another configuration that we can use to create a different instance of our DSL. So I'm going to copy this, and now back over here, we'll paste it into here. This was our initial DSL context, and the Kotlin equivalent of that Java is a lambda here that takes a TRX of type configuration, and is this block here. And that configuration is jOOQs. And then we want to use this configuration to give us another DSL. So we say val transactional DSL is our TRX.DSL. And if we use that in here, let's see what happens. Okay, we're not quite there. We're still seeing this modification. I think the problem here is that we're waiting here and here, but as soon as this code is let go, it can save and exit the transaction before this load down here gets to load. So I think what we're going to do is we're going to wait twice. We wait in this barrier again and run that, then it passes. Actually it passes though because this thread is always stuck here. So what we're going to do now is we're going to wait on the barrier again, and show that if we do, which lets this one run, then we get our initial stock list by loading. Technically, I think we should also make sure the thread has finished. So we will remember the thread and we'll do thread join here. And that will make sure that this transaction is always finished before we load here. Check that. Okay. We have, however, made quite a few changes since we saw the failure without the transaction. So in order to check that, in here we'll not use not the transactional DSL context, but the normal DSL context, and check that breaks in the way we expect. So it does fail, and it fails because we're seeing the saved stock list in this initial load here. Replace that with our transactional DSL context, and the transactions are working as we expect. What I think I'm going to do now then is to implement the same test, but with our in transaction block here. So I'm going to take this and duplicate it. We're going to call this transaction spike. And here what we want is, instead of this DSL context transaction, we want to be able to say items in transaction, and we'll use our items save initial stock list. Now that's not compiling, and the reason is that we don't have this context of IO we need. A problem we can fix by saying that this is a context IO function, because if you remember, we made our items contract, extended our items contract with this IO resolver that means that we can write context functions for our tests. Okay, returning here. We'd also like it that we use the items methods in here. So in here we'd say items dot in transaction, and we would say that this is items load will be a success of null stock list. That's because our items interface returns result types here. And similarly down here, this should be initial stock list. Run that, and it unsurprisingly fails. Okay then, let's see the whole of that test and move over to our jOOQ items. At the moment, this is using no TX, which is our way of saying that we don't support transactions. But you may remember that in case of exposed, that's here, database items, we created this exposed TX context. So let's copy that and have a jOOQ version of that. So this would be a jOOQ TX context, and I think I'm going to start using OOQ in lowercase. Now, if we had one of those, then our jOOQ items would be items of a jOOQ TX context. And that would make this a context that took jOOQ TX context, and both of these functions would need jOOQ transaction context to run. Now we need a jOOQ TX context to pass to this block. So we can go to the base DSL context from this jOOQ items and say transaction. And that's the equivalent of the code we've got here, which is the one that takes a TRX, which is configuration. Now inside here, we need to create a jOOQ TX context. This is our TX context, maybe with a lower TX, and that's going to be a jOOQ TX context. And inside here, we don't want this transaction, we want the transactional DSL context. So that's going to be DSL context. That's the one we get from trx.dsl. That's equivalent of the code down here. And now we can pass that to our block. This almost compiles. The problem is that DSL context transaction we can't return out of. It's not an inline lambda. It's not even Kotlin. But going back to the jOOQ documentation, we can see here we've got this transaction result method, which allows us to actually yield a result. So let's go back and we'll change this from transaction to transaction result. In which case we take return out of here, but return it from here, which makes this into an expression. Are we there? Well, we'll run the test to find out. Now, our first issue is that we haven't fixed the tests. So we have this jOOQ TX context that is going to be the type of our test. Now we're able to compile, but we're still not quite working. And the reason for that is this unused DSL context here. At the moment, in jOOQ items, when we save, we're using the DSL context, which is the one passed in here, but that's not actually transactional. We can fix that by making this a val. And to avoid confusion, I'm going to call this transactional DSL context. And then that is what we want to use in here and in here. And because of the wonders of context functions, this transactional DSL context is being taken from the context of jOOQ TX context, which is passed into the block here. Is that all right? Cross your fingers. And we're good. I think I'm going to have a quick tidy up and check it in before it has a chance to realize that it could fail. I think maybe we will rename this with the lowercase and the same with the tests. And now let's run all of our tests. And we seem to have some issue with the rename. Let's just have a little look. I suspect that we just need to rebuild. And now we run into a problem where I think files with the same classes but with different capitalizations aren't properly recompiled. I think in the past that's been a question of deleting the build directory. Let's just see where that gets us. Of course, there's everything to rerun. jOOQ to rebuild its code generation. And we're all good. Phew. And finally, I think I'm going to remove this transaction spike because we've taken the code out of there and put it into the production jOOQ items. And now commit. Implement transactions in jOOQ items. Good. Just for fun, I think I'm going to try running this code against exposed. So we'll go to our database items tests and paste it into there as well and see whether that works there. It does, that's nice. We now have this duplication in the two tests, which is a bit irritating. We can put that in items contract as a not test method. And then in our jOOQ items, we can say that this is an override that calls super transactions. We can open up there, see whether that works. And it does, and we will do the same thing in our database items test. But in here, we'll just add a fail to check that we are running. We are good. Delete that. And everything's splendid. And now commit that as test transactions in exposed. Good. Before we say we're done for the day, there are a couple of little things in the back of my mind. The first is that I wonder whether or not we can save an empty stock list. We'll return an empty stock list before we saved anything, but can we save a stock list with nothing in it after we've already saved a stock list? In order to find out, I'm going to duplicate this test, and this is going to be it can save an empty stock list. So we're going to save an initial stock list so that we can load it, and then instead of just removing some items, we're going to remove all the items. I'm going to save an empty list. Then we're going to save that and then check that we can reload it. And run the tests. And lo and behold, they fail, and both the jOOQ items tests and the database items tests fail. Now the reason for that is that our clever scheme to have database columns for the last modified, where we save all the data for an item with this common last modified from the stock list, means that if we have no items, we don't go into this for each loop at all, and we don't save anything. That's a bit embarrassing, really. I suppose at least it shows that I'm being honest when I say I haven't planned the solution weeks ahead. We are actually doing test-driven development here. But what can we do about it? I think we could solve this problem with two tables, where we have one table for every save and another table for the items in that save. But that's quite a bit more complicated. We could solve it, though, if we had an item that didn't really represent an item. It just represented the fact that we saved something. So the sort of thing I'm thinking of is that in here, if we say, if our stock list is empty, we do something else. And we need to make that compile. And for the empty case of the stock list, we can insert into items a special item. Now we don't have an item because the stock list is empty, so we need to make up values for it. And if we made up an ID of no items saved, we'd need the stock list last modified. The name would be this is not an item, say. The quality, we have to give it some sort of quality that is an int, and probably a non-negative one. Let's use int max value. And the sell by date we're allowed to be null, so we can put that in there. And now if we can detect that that's the thing we saved, we know we should be returning an empty stock list. So let's have a look at that code. Now we left this in a bit of a mess. Let's first of all rename some of these things. This is not items. This is last modified to items. This is not last modified. This is last modified to item. Now I think we can say is empty is if we have a last modified to item, the second one will be the item. And if that has an ID with a value, this is the value of the thing we put in the top, which was no item saved. Just looking at proof of concept at the moment here. Then in here we can return a stock list, and if is empty, empty list, else that thing. Are we feeling lucky? Well, let's run the tests. Quite compiling here. We have to continue our little chain of question mark dots. Try again. And now our jOOQ items tests passes, and our database items, the one we implemented in expose, doesn't. Well, that's a start. Now let's go and see if we can tidy that up a bit. We go up here. I think we should be able to create an item that represents no items. It's effectively what we've done here. So let's say val, often we call this a sentinel. So this would have an ID, is an ID of no item saved. And I'm going to double bang these. They return null, but this is a constant, so if it ever passes, it will continue to do so. Now the name is going to be a non-blank string on our this is not an item. Let's take that. Our sell by date is null. And our quality is a quality of int max value, because you know that qualities are non-negative, so we can't use minus ones. And again, as this is a constant, I think it's safe to use the double bang. Now we're set up with that, I think we can abstract what it is we want to save. So we say val to save is if the stock list is empty, then it's going to be a list of just our sentinel item. Otherwise, it's going to be our stock list items. That allows us to take this out of here, and the action here is now to save for each. Try running that. That still passes for jOOQ. And now in our load, I think we could call this actually first last modified to item. And then we can say, is the first last modified to items second thing equal to our sentinel? Let's try that. Good. And now I'm not going to claim that's a nice solution. We may come to regret it, I don't know. It has the advantage that we have strings in here that if they get into our UI, they should be noticed and somebody will report them. I think it may be good enough. I'm going to make that private, tidy that away. And I'm a little suspicious about these, so I think we should say question mark colon error invalid ID. This is invalid name. This is invalid quality. We don't have tests for those, but that's just a little bit of better diagnostics if they do go wrong. And that would allow us to inline that. Put the arguments on separate lines. Add the names of the arguments here. Inline that, and that. Making this an expression body. Run those tests one more time. Good, good. And I think this may be the time where we say that maintain two database items isn't worth our while. We have to choose. And on the whole, I'm most impressed with jOOQ, so I think I'm going to get rid of expose now. We're not using either of them in production, so that's all right. Let's go to our database items tests. Delete that. And similarly with our database items. Delete. And lastly, if we go to our Gradle build file, we can take out exposed from here and build and run. That seems to crash the compiler. And actually, as I think of it, we're still using exposed to create our database schema. So I think I'm getting ahead of myself. Let's undo that. Roll those two files back until we've some way of building the database. Cross your fingers. So now we have a bit of a moral problem with the database items. I think we're going to go to the database items and say, let's override can save an empty stock list for that one. So we'll go to database items tests, and we're going to override can. It's not going to complete for me, is it? Ah, well, can save an empty stock list. Take all of this and make it empty, which means it needs to be open. Can we finally run? Yes, we can. So let's commit that as save an empty stock list in all but exposed. All right. The second thing I wanted to look at was around spanning transactions. So here in the test we wrote earlier, we are running two transactions, one that can't see changes and one that can see changes. What I'm interested in though is if we were to take this items in transaction out and that one, then what will happen? What might happen is because this is all one transaction, it will never see any changes from this one. Let's run it and find out. Well, that's passed, and that means that it has seen the changes. I think what's happening here is we're seeing changes that are committed to the database from this transaction in the middle of this one. This transaction is able to see things that have been committed by this one. It's not truly serializable. What I don't know at the moment is how to make that not happen. I don't know how to set the transaction isolation level for jOOQ. One of the reasons I might want to do that is because having a transaction isolation level of serializable is, I understand it, quite useful for event sourcing. I don't think it's unsafe here, but I'm still learning about the effect of different isolation levels. And it would at least be nice to be able to play with it and see that I'm right, that that's why this is behaving as it is. In the meantime, though, I think we'll just undo that, leaving us where we were when we committed last time. Well, as I just realized a few minutes ago, if we're to use jOOQ but not expose, we're going to have to find a replacement for expose create missing tables and columns. Because at the moment, jOOQ is reading its schema from the database, and the database is being created by exposed. The grown-up way to create schemas for databases is by migrations, where we specify the database we want, and then how to migrate from the first version to the second and third, and so on. Doing a bit of research, I think we'll be using Flyway for that, and jOOQ appears to have good integration with Flyway, but I have quite a bit to learn there. If you'd like to see me learning that, then please subscribe to the channel. And if you've enjoyed this episode, then I think you'll enjoy the book that I wrote in that price called Java to Kotlin, a Refactoring Guidebook, details of which are in the show notes below. Thanks for watching.